Okay, for this video and the next two videos maybe, I'm not sure how many at this point, we're going to find parameterizations of spheres, parameterizations of surfaces. Now there's basically, finding a parameterization is kind of an art. Gosh, I can't believe I said that. When finding a parameterization, there's several things to keep in mind. One is you kind of have the whole shape. So we have a whole sphere, or the next part is to find just a portion of this sphere. So we want to usually try to work with a coordinate system that is best for whatever it is we're trying to do. Okay, so sometimes this might be just regular Cartesian coordinates, sometimes this might be cylindrical coordinates, sometimes this might be spherical coordinates. It all just depends on the shape that we're parameterizing and the parameter domain, meaning what values are the parameters allowed to take. And hopefully this will become more clear. This will make more sense as we go on. So let's look at this first question. Find a parameterization for a sphere of radius 2 centered at the origin. We're going to do the first part and then, of course, do the second part. Well, so a parameterization means we need a vector function of the form r of st. Okay, so when we want to find the parameterization of something like a sphere, we should be thinking spherical coordinates. So let me remind you that if you have a point x, y, z, the spherical coordinates of this point are the following: rho cosine theta sine phi, rho sine theta sine phi, and then rho cosine phi. Okay, and review what spherical coordinates are to remember what the theta and phi are. The theta is essentially the same theta from polar coordinates. The phi is the angle so if you think about the point x, y, z, what is phi? Well, imagine the line segment going from the origin to x, y, z. Phi is the angle made between that line and the positive z-axis. Anyway, these are spherical coordinates. So this gives the full spherical coordinates give three parameters: rho, theta, and phi. We need two parameters. Well, notice that for a sphere of radius 2, rho is equal to 2. So for a sphere of radius 2, all of these rhos are equal to 2. So what this says is that if you want the parameterization for a sphere of radius 2, this is r of phi theta is equal to, we want it to be a vector function, so this is 2 cosine theta sine phi, 2 sine theta sine phi, 2 cosine phi. And here, the parameter domain, these are the values that theta and phi are allowed to take. So D is equal to all of the sets, all of the phi and theta, where phi goes from 0 to pi. Remember, by definition, phi goes from 0 to pi, and theta goes from 0 to 2 pi. Okay, that is the answer to the first part of the question. So now let's look at the second part of the question, the part of the sphere that lies in the first octant. That is where x is greater than or equal to 0, y is greater than or equal to 0, z is greater than or equal to 0. Well, the parameterization stays the same. I mean, the r of phi theta is the same thing that we have up here, but what changes is the parameter domain. So now we need to figure out what the parameter domain for phi and theta are. Okay, so what about phi? Well, let me try to draw a very bad diagram of what's going on here. So let's say like this is the x-axis and this is the z-axis. The x-axis, we could also be the y-axis. Okay, so this is the sphere. So this here is the angle that phi makes. That looks more like a 6. Okay, so we want phi to go from here to here. So if he's going to go from 0 to here, that is from 0 to pi over 2. Okay, and now what about theta? Well, now let's look in the xy plane. So this is x, this is y, and say the positive z-axis is coming out of the screen. Well, we want theta to go from here to here. This is what theta is. It goes from here to here. So theta goes from 0 to pi over 2 as well. Okay, so finding the parameterization of a sphere, believe it or not, sort of obviously uses spherical coordinates, or maybe not obviously if you're not thinking in terms of spherical coordinates, but that's what it uses. And then, so if you want the whole sphere, the parameter domain is just phi going from 0 to pi and theta going from 0 to 2 pi. Those are just the parameter values that we have in spherical coordinates. But then when we want to restrict the sphere to just this I guess, what would it be, eighth of the sphere, we have to restrict the parameter values for phi and theta. In the next video, we're going to look at parameterizations of some paraboloids and other things.